Welcome to qnawire.
Over here, we're going to have three different rates for three different experiments, which each of them have in common that either you change the concentration of x2 or you change the concentration of y2. So in the first experiment, what we have is that the concentration of x2 and y2 are the same. So concentration of x2, concentration of y2, and the initial rate. We have 0.1 molar on each of them. I'm going to omit the units over here. And we have an initial rate of 0.06227. Next up, on the second experiment, what happens is that they kept the concentration of x2 the same, and they doubled the concentration of y2. And what happened is that, essentially, the rate doubled. In experiment 3, they did something similar, but now doubling the concentration of x2 and keeping the value for the concentration of y2. And what happened was that the rate quadrupled. So, without having to do any calculations, we can already say that the reaction is order 1 with respect to y2 and of order 2 with respect to x2. Now let's see how I can assess that directly using the equations. Remember that the rate of a reaction is equal to the rate constant times the concentration of the reactants to the order of the reaction. Let's call the order of reaction for x2 A and the order for y2 B. We want to find the values for A and B. So what we're going to do is divide the rates of two different experiments. Let's say we do rate of experiment 1 and rate of experiment 2. For experiment 1, the rate is equal to my rate constant times the concentration of x2, which is 0.1, to the A, times the concentration of y2, which is 0.1, to the B. On the other hand, for experiment 2, the rate is going to be equal to my rate constant times my concentration of A, which is the same, 0.1 to the A, times the concentration of y2 to the B, 0.2 to the B. And surprise, surprise, what we can find here is that things are going to cancel out properly. K and K and 0.1 to the A and 0.1 to the A cancel out. And this is going to give us that rate 1 divided by rate 2, which is equal to 1 half, is equal to 0.1 divided by 0.2, and all of this to the b, right? So the equation that we need to solve is 1 half is equal to 1 half to the b. What needs to be the value for b for this to be true? B needs to be equal to 1. So order for y2 is equal to 1. Next up, we can do the same thing for the first and third experiment. So let's say rate 1 divided by rate 3. And here, just to have the result a little bit more direct, I'm going to actually divide rate 3 divided by rate 1 of experiment 1. Okay, the constants are the same. For experiment 3, what we have is that the concentration of x2 is 0.2 to the A, the concentration of y2 is 0.1 to the B, and for experiment 1, k times 0.1 to the A divided by 0.2 to the B. Sorry, by 0.1 to the B. So now what cancels out are the concentrations of compound y2 to the B, and when we end up with, when we divide rate 3 by rate 1, which is 0.2491 divided by 0.06227, is essentially 4. So 4 needs to be equal to 0.2 over 0.1 to the A, which is 2 to the A. With this, we can readily see that A is equal to 2, thus the order with respect to x2 is equal to 2. So my rate law can be written as my rate constant times the concentration of x2 squared times the concentration of y2 to the 1, but we can omit the 1, of course. That would be all. Thank you very much, and have a good one.